Hi there, this is Year 12 Maths lesson video on finding the area under a curve, exercise 15e. And this is effectively an example of it. We've got this function and we want the area under this curve. Notice when I say under the curve, I mean between the curve and the x-axis up to some point. So let's have a look at a couple of questions. And now in the last area then, last lesson then, we did actually see this link, that the integration area under a curve were sort of linked in some way. So this first question says, use integration to find the area bounded by the curve y equals 3x squared plus 2, which very kindly has been drawn for us. So that's my curve. Notice this is a parabola, quadratic shape, hitting at 2. And it says find the area bounded by, now this is a typical way of writing it, bounded, as in boundaries, bounded by the curve there, the x-axis there, and the line x equals 0 there, and the line x equals 1. So you can see the shape I've coloured in is actually the area I want. Now one thing you should be conscious of is you should be looking to see, is the area you want, does any of it go below the x-axis? And ours doesn't. I mean, the kind of questions you might happen like that might be, say the curve that looked like this, and I said to you, find the area between, so I don't know, this point here, 1. Sorry, this is 0, I don't know where I got 1 from, and this point over here, 4. And you'll notice that would involve a little bit of area there, a little bit of area there. Both of those would be above the line. Then this bit here is below the x-axis, and this matters. So if we ever see examples like that, we'll have to be careful of that. But here all of ours is above the line. There's the x-axis, and it's all above it. So basically what that means, it means I can just integrate. It says area is the integral meaning we can integrate. So let's integrate it before the solution jumps up here. I'm going to integrate 3x squared plus 2 dx. That just means that's my letter between 0 and 1. Those values there matter. If I do this, add the power, divide by the power. 3x cubed over 3 plus 2x. Now do remember, when you've got these definite integrals, you don't put a plus c, you just put the square brackets. And interestingly, the 3's cancel. What was it? 0 and 1. So this is x cubed plus 2x between 0 and 1. Now if I put 1 in, I get, well, what is it? 1 cubed is 1. 2 1s are 2. Well, that's easy enough. Put 0 in. And the great thing about these, if you put 0 in, you get 0 out. So my answer is 3. Okay. My area is 3. Now notice I've written 3 square units, but 3 is good enough. Now I've put this up here because there are ways and means to do this, like almost like a cheaty thing. So I'll use that at the end once we've got our answer. It says find the area bounded by the curve y equals x squared minus 2x, which again has been drawn for us. Oops. Between the x-axis and the lines x equals minus 1. Well, minus 1 is there actually. And x equals 1. Oh, well, that is there. Oh, this is one of the ones I was telling you about. There's a little bit above and a little bit below the line, and you can see this bit is above the line because by the line I mean the x-axis, but this bit here, that is below the line. Now when you get these two separate parts, you're going to have to split it into two, and the important number here is that it crosses at 0. So we're going to have to split it into two parts, this part and this part. So I've called it part A and part B. And I'm now going to find these two areas. Now A, you should be aware, is going to give me a positive answer. When it's above the line, as we saw just now, you get a positive answer. But whenever it's below the line, it's negative. That's the bit we're going to have to be careful with. So we're going to split it in two parts. Let's do it here actually. I'll do the integral. I'm going to say this is A. A is the integral from, well, my lowest number is minus 1 up to 0 of x squared minus 2x dx. So when I do this, I get add a power and divide by that power. So a third of x cubed minus 2x squared over 2. That's just minus x squared. That's between 0 and minus 1. So between 0 and minus 1, if I put 0 in, I get 0, and I put 0 in, I get 0. So lots of polynomial expressions will get 0 with. If you put 0 in, you get 0 out. But the minus 1 I've got to be a lot more careful with. Minus, I'll put minus 1 into this. Minus 1 cubed is minus 1. So times that by a third, I get minus a third. Minus 1 squared is 1, but it is a minus, so it does become minus 1. So this is, I think, minus 4 thirds. But there's a minus of minus 4 thirds, so I think that's plus 4 thirds. And I did predict that A would be positive, and it is positive, so that's a good sign. Now let's do B. Now it's exactly the same integral, but just different limits. It's now between 0 and 1 of x squared minus 2x. And even though I'm doing this twice, of course, I know the answer is going to be a third of x cubed minus x squared. It's just got different limits. No plus c, of course, because I don't need it. Equals. I've still got this line here, but other than that, I'll ignore that. So if I put 1 in, I will get, let's just cross that out, I will get a third of 1 cubed is 1, so therefore a third minus 1. Because 1 squared is 1. That's right. And I put 0 in, I get 0 out, as I've seen before. So a third minus 1 is actually minus 2 thirds. And I did predict that this answer would be negative. And it was negative. And notice it's negative because it's underneath this x-axis. So I've got two answers. 4 thirds. And notice I've ignored the minus. The answer was minus 2 thirds. That's not wrong. That is right. But the minus just means it's below. If I'm just calculating the areas, and I don't care if it's above or below, it's 4 thirds plus 2 thirds. And 4 thirds plus 2 thirds makes 6 thirds. And 6 thirds is 2. There we go. 6 thirds is 2. That's the answer. You wouldn't get that right. Now, there is a button on our calculator. I'll try and find it. Let me just try and find it now. Right, I found it. It's there. And that button there allows you to type this in. So I'm going to do it now. You just press it. And you can type in using the X button, which is very happily right next to it. You can type in what our expression was. It was x squared. So type in x squared minus 2x. Again, using the X one. And if you press the right, you go to the limits. And I'm going to put, well, it went from minus 1 to 1. So I'm just going to type in minus 1, negative 1. You'll need to use this negative here. And then press the up button to go up to the other one, up to 1. Now, if I had just typed this into my calculator, and this is a cheaty button that will let me work out an area, but this won't take account of negative. So if I press equals now, it reckons the answer is 2 thirds. So just be aware there is a great button on your calculator, but it only works if all of it is above the line, above the x-axis. If any of it's below the line, you're going to get a wrong answer. So just be warned, there is a great button on our calculator which we can use to check our answers. We still need to show our working out, but that button has potential for getting you errors. Here's another example, x squared minus x minus 6. Now, the one thing I'm not sure of is the shape of this. So, I mean, if it was me, I'd be typing this into my calculator. Because I've got a calculator that does it. You, on the other hand, wouldn't know what that is. So I suppose if we're going to get this in an exam, we're going to have to try and factorize that. So what's that? It's x minus 3, x plus 2. Now why does that help us? Because we can now draw it. Plus 3, there it is. Minus 2, do you remember you always change those signs? And it's a positive x squared, so I know it's going to look something like that. What does it want? It wants it between 1, there's 1, and 5. Now that matters, 5's over here somewhere. So, trying to fiddle my picture a bit so it looks better. You can see I've got a bit above and a bit below. And those two sections I'm going to call A and B. I'm going to work them out separately, otherwise I'll get it wrong. So let's do A first. A is the integral from, what did I say? It's from 1 to 3 because it crosses at 3. And that's why you draw the picture, so you know where it crosses. 1 to 3 then. of the curve x squared minus x minus 6 dx. So integrate it, I get x cubed over 3 minus x squared over 2 minus 6x. Don't put a plus c, put a square bracket, and it's between not 1, yes, no, 1 and 3, not 1 and 5, because I've split it into two smaller parts. 1 and 3 is right. So I put 3 in, I get 3 cubed is 27, divided by 3 is 9. 3 squared is 9 over 2 is 9 over 2, so minus 9 over 2. 3 sixes are 18, so that's my first bracket. Minus, put 1 in. 1 cubed or anything is 1, so it's great. 1/3 minus 1/2 minus 6. Work out both of those. You might as well just do it on your calculator. So I've got 9 minus 9 over 2 minus 18. So my first bracket, I've got minus 27 over 2 minus, what have I got? 1/3 minus 1/2 minus 6. I get minus 37 over 6. Notice it's minus and minus really though. So it's, what did it do? It was negative 27 over 2 minus, and bracket, negative 37 over 6. I get minus 22 over 3. It's not very nice, is it? So minus 22 over 3. I could have done it carefully, but I've just used my calculator to make it easy for myself. Notice the area of that section then isn't a minus. We just say the area is 22 over 3. Now I do the same thing for b. b is the integral from 3 to 5 of the same function. So I know it will be x cubed over 3 minus x squared over 2 minus 6x between 3 and 5. If I put the 5 in, I get 125 over 3 when I cube it, minus 25 over 2 minus 6 5s are 30. And then I have to take away. Now, when I put 3 in, I know what I've got when it was this. It was minus 27 over 2. So you don't have to do it again. You can do it. It's a lot easier if you don't bother. So I'm going to just work that out. 125 over 3 minus 25. Minus 25 over 2. You can tell I made a mistake as I was doing that. Minus 30. And then if I minus the minus 27 over 2, I get 38 over 3. 38 over 3. And of course it's positive, so that area is 38 over 3. Now, ignoring that minus from there then, I've got 38 over 3, I've got 22 over 3. That sounds like the total area is 60 over 3, which is 20. Is that what the answer said? Yes, it did. They've got a posher picture that I had, but you get the idea. Now, there's a couple of questions which we'll save for the lesson. We'll do these in class. It'll be a nice way to start the lesson. But other than that, I've got some questions for you on exercise 15E, and I think it's a nice place for us to stop.